person suffering from vision defect or defects sees more clearly underwater. He is suffering from. We know that at the underwater, it means refractive index of outer medium is a greater value when comparing with refractive index of air. If we can observe a point like this in air, we can see a distant object in water. Therefore, image of, we can consider that he can see long distances. For the air medium, he can see an object like this. But actually he can't see this because of he has a eye defect. But in water, he can see this one because of he can see long distances. Therefore, he can see only long distances. It means he should have short sightedness. Short sightedness, then answer is 1. A certain person can see objects clearly only when they lie between 0.75 meters and 1.8 meters from his eyes. To see distant objects clearly, which of the following lenses are most suitable for him? He can see objects from objects between 0.75 meters and 1.8 meters. His vision range of vision is 0.75 meters to 1.8 meters. To see infinity, an object in infinity should be form an image at 1.8 meters. Therefore, he can see infinity by using a lens with 1.8 meters. We know that we are using concave lenses to see infinity. Concave. Then, when considering range of vision, we can see the maximum range, maximum distance 1.8 meters. Therefore, to see infinity, he should wear a concave lens with 1.8 meters. But there is no an answer with this value and this type of lens. Therefore, they will ask correction for this one. But when see 0.75 meters, it is the smallest distance he can see. Therefore, we can use a lens to bring an object in infinity to this place. To bring an object from infinity to this place, we have to use a lens with focal length 0.75 meters and it should be a convex lens. Then convex length of focal length 0.75 meters. Answer is 4. In the human eye, the location of image of an object is adjusted to appear the retina by changing the human eye, the location of image of an object adjusted to appear on the retina by changing focal length of lens. We know that when see a far object, the lens is like this. There is a high focal length. To see a near object, focal length should be like this. It means there is a small focal length. Then it is changing focal length. Then answer should be 3. And a near point at 1 meter, the lens needed to change this to 25 centimeters each. Near point 1 meter. It means he can't see 25 centimeters with natural light. Therefore, it is long sightedness. By using a lens, we have to make an image of point he can see. Point he can see is 1 meter. 1 meter means 100 centimeters. Object should be placed at 25 centimeters. By using the lens, an image should be formed at the nearest point he can see for the object at 25 centimeters. Then he can see 25 centimeters by using corresponding lens. Then I will use lens formula 1 over V minus 1 over U equals 1 over S. Image distance 100, object distance 25. We have to find S. When finding focal length of wearing eye, it means when calculating focal length related to eye defected eye, we can use without sign convention, because of all these lenses are positive values. These distances are in opposite direction of light rays. We have to get from eye to the object distance and image distance opposite to the light rays. Therefore, we can simplify without using sign convention. LCM 100, 1 minus 4. It is 1 over F. F is 100 divided by minus 3, minus 33.3 centimeters. Then minus means it should be a convex lens and focal length should be 33.3. Convex lens is focal length 33.3. Then answer is C. A person can see clearly objects placed 25 centimeters from his eye when he wears spectacles of power minus 1.5 diopters. Without spectacles, he can see the object most clearly at the minimum distance. I will find the focal length of weared lens. They have given power. Power is 1 over focal length. Power 1.5 diopters. Then focal length 1 over 1.5. This one is in meters. We are using diopters for power. Then using focal length in meters. Then I will convert it to centimeters. 1 over 1.5 multiplied by 100. 1000 divided by 15. We can cancel out 15 divided by 5, 3. 200 divided by 3. And he is using this lens to see near point. Near point, to see near point, it means he has long sightedness. So the long sightedness, we have to use convex lenses. Then I will, this one is convex. Then I will use lens formula. 1 over V minus 1 over U equals 1 over S. Image should be formed at 25 centimeters. To see the image should be formed, image should be formed at the nearest point we can see without using spectacles. Object distance is 25. We have to see object at 25. Focal length is minus 200 over 3. Then 1 over S means 3 over 200. Then I will simplify it. 1 over V equals minus 3 over 200 plus 1 over 25. LCM 200, 200 divided by 201 minus 3, 200 divided by 25, 8 plus 8. Then V value is 200 divided by 5, 40 centimeters. Then he can see 40 centimeters from his eye. Then answer is 4. The maximum focal length of normal eye is 2.5 centimeters. But spectacles are required for him to view an object comfortably at 25 centimeters. Maximum focal length means you can observe maximum focal length for the eye lens when see a far object. It means rays parallel to main axis are met at the maximum focal length. It means diameter of eyeball is given as 2.5 centimeters. Now he has to use spectacles to see an object 25 centimeters. Then we can use 1 over V minus 1 over U equals 1 over S for the length of optical instrument. 1 over image distance should be 2.5. It is a minus sign. Light rays are moving in this direction. Minus 1 over object distance 25. Focal length is the problem. 25 centimeters is the plus sign. Then I will simplify it. LCM 25 minus 10 minus 1. Then F equals 25 divided by minus 11. It is approximately minus 2.3 centimeters. Minus means converging length. Converging length 2.3 centimeters. The answer is 4. A person who is long-sighted at near point at 50 centimeters. What spectacles are required for him to view objects comfortably at 25 centimeters? By the wearing lens, an image should be formed at 50 centimeters. It is the nearest point he can see. Object distance should be 25. Then he can see the object at 25 centimeters because of an image is formed at 50 centimeters. Then LCM 50, 1 minus 2. Focal length should be 50 divided by minus 1 means minus 50 centimeters. Minus means converging length of focal length 50. Then answer is 2. A certain person has a defective eye. The distance between eye lens and the retina of the eye is 0.025 meters. But the power of the lens of the resting eye is 45 diopters. What shall be the type and power of corrective lens he should wear in order to see distant objects? We know that to see distant objects we have to wear convex lenses. If there is a eye defect, if we can't see infinity, we have to wear convex lens. And by the convex lens, an image should be formed at 0.025 meters. It is the distance between lens and retina. Therefore, object distance is infinity. Therefore, focal length should be 0.025 meters for the wearing lens. Then we can find the lens power. Power is 1 over focal length 0.025. It means 1000 divided by 25. 1000 divided by 25, 40. But they have given lens power for the resting eye is 45. It should be converted to 40. Then we have to use an extra lens with lens power 5 diopters. Then convex lens 5 diopters. Answer should be 4. There is a problem with answer numbers. Answer should be 4. Convex lens and power should be 5 diopters. A defective eye of a person has a near point 0.5 meters. The magnitude of power of the lens that the person has to use in order to bring the near point to 0.25 meters. Again, by using the wearing lens, an image should be formed at the distance he can see, 0.5. For the object at 0.25. Then we can find S value, SCM 0.5, 1 minus 2. 1 over F is minus 1 over 0.5. 1 over F is the lens power, then we can get power. 1 over 0.5, it is in meters, therefore we can obtain the answer in diopters. 1 over 0.5 means 2 diopters. Then answer should be 1. A certain person cannot clearly see objects located beyond 1 meter from the eye. The defect can be corrected by wearing. He has to see infinity. To see infinity, infinity should bring to 1 meter. It is the maximum distance he can see by the wearing eye. To bring infinity to 1 meter, focal length of the wearing lens should be 1 meter. And we know that to correct short sightedness, we are using concave lenses. In a concave lens with focal length 1 meter, answer is 1.